This is the binary rifle inspired by the Halo franchise. I started it using a drawing and extruded it, and then I started to cut it down and add chamfers and extruded cuts to give it the shape that you see before you, and then I added a detachable scope and a revolving chamber, as well as two flaps that can open up to allow for reloading ammunition. This is the hand of the exosuit, consisting of fingers all conjoined by ball bearings, as well as a wrist that is capable of extension and flexion.
So here's the design of our arm of our exosuit. Adjustable part in the middle with 4 screws to make sure it could be longer and shorter. For the other part of our arms, it contains 1 stepper motors for the hands to rotate, and the same things do with the adjustments. Right in the middle, it's our gearbox for our arms, containing the total of 27 gears, and a gear system that could produce more torque for our arms to lift a great amount of force, using the same stepper motors. 2-to-1 ratio is used in this gearbox.
This is a 2-axis shoulder joint to simulate a human ball and socket joint. It has a worm drive with a helical gear to increase the torque, decrease the speed. It's about a 36-to-1 gear ratio. There are 4 small thrust bearings on either side of the worm drive to hold it in place. There's a base plate to connect to the body, 2 cylindrical connections that clip onto the arm, and a sheet metal casing covering all of the components.
This is the torso piece. It is a very simple piece consisting of 1 part with several different cuts, extrudes, and fillets to make the body look seamless. It was heavily inspired by a plate carrier used in the military. The body has also been designed to have a spine component to it. The spine is made of a single invertebrate stacked on top of each other. The purpose is for the entire exosuit to move alongside with the person's back and have flexibility within the body.
This is a single-axis simple pivot joint along with a mechanical motorized center. There's a pinned armor plate on the side to protect the swivel joint, along with a physical mechanical limiter to keep your leg from hyperextending. The motorized single-axis swivel joint runs on a mechanical system with a planetary gearbox, with small gears paired to big gears to increase torque. This is designed to give you as much leg strength as possible without being too speedy or fast.
Okay, so for my part, we have a detailed design of a hybrid between an exosuit and an actual human feet. You have 6 independent articulated joints that is used to actually grip the ground in order for the exosuit to have a firm shot when its firing is done, as well as a spot so it can lock in a certain position. We have joints acting as the overall toes and joints that can articulate as the actual ankle, as well as a platform for the human to sit down as it's deploying the exosuit.